presentations. I would like to give word to all of you. Maybe let's start with our partners, because I see we are not just partners here, we are also stakeholders here. Maybe your representative organization and field of background. Maybe let's start with Manuel Murcia as the lead partner. So, yeah. Manuel, you can introduce yourself and then.
Yes, sorry, I was a technical problem with the sound here. In our case, region of Murcia is very interested in these good practices, because we have a great problem with especially with a salty lagoon, and I think the better treatment of our drainage could help to solve our problem, and I think would be the base of our action plan. Thank you.
Thank you. Maybe we have someone from Greece. I see. I think I saw someone. Maria, yeah.
Hello. Can you see me? Okay. Can you hear me?
Yeah.
Okay. I'm here as a representative from the ministry, but we have also two stakeholders, Mr. Papakostadinu and Mr. Spiris. If they would like to say also hello. I don't know if they can hear me.
Good morning, everybody.
Hello.
Hello.
I represent here my water company. It's the water company of the city of Larissa. It's a city in central Greece. And I'm interested in your project because I'm the manager of the water treatment, wastewater treatment plant of my city.
Mm-hmm. Thank you. And I heard you had one more stakeholder, Maria. That's right.
Yes, it's also Mr. Spiris. I don't know. Just a moment. I saw him before. Maybe there is some issue with the connection. He will connect with us shortly.
Okay, then maybe we can continue with our Poland partners, Selocki region. Ivana, I hear you here. We don't hear you, Ivana.
Do you hear me now?
Yes. Perfect.
Yes. Hello, everybody. Nice to see you. Thank you for inviting us for study visit. And as you know, Lotski region has a problem with water. As other regions, we have a lack of water, and we are interested in technical solutions connected with reusing water. It is possible for our region to use it mostly in producing, in processes of production, but with we will see your good practices in context preparing our action plan. Maybe in the future we can use water, for example, for car washing. It would be great.
Okay, thank you. And do you have any stakeholders from Poland?
My stakeholders will inform me that will attend. For example, PH Sebastian Szklarek, but I don't see him now. Maybe he will join. And also Marta Asner, she isn't stakeholder, she is representative of our organization, but she is managing in regional operation program. And I saw her, Marta.
Marta, you want to say something?
Yes, hello everybody, and we are very interested in your practice. Thank you.
Okay, thank you. So let's move on to the Czech Republic. So our partners from Regional Development Agency of Parabits region, is someone here? Hello. Didn't see. Yes, wasn't there? Someone is. Ursa, maybe you can turn off your microphone. Okay, I guess from Czechia we don't have any right now. Let's move to Energy and Water Agency. Do we have representatives from our partner there? I guess not. So FLA, Lombardy region. Also, I think no. Then from Germany, do we have anyone from Germany?
Hey everyone, my name is Sasha. I'm working for the East Frisian Water Board in Germany. My colleague should be joining in a couple of minutes, but I don't really have a webcam right now, so sorry for that.
Okay.
Yeah.
Okay, thank you. And European Medicine and Water Institute Foundation, Anna.
Hello, once again, good morning. Yes, as you have said, we are just advisory partner from our AQUARES project, and we are glad to be here, of course. We hope to learn many things, or just to keep updated on issues which are explained in your program. And we are glad to have here today with us as well Jaime Fraile, if you don't mind to introduce myself and to him. Maybe he wants to say something else, or just to add something. He's from Segura River Basin, from Murcia.
Yes. Hello, everybody. Thank you very much for inviting me here. Like Anna said, I work at the Segura River Basin organization. And like Manuel mentioned before, we have a very serious problem with the ecological status of the Mar Menor coastal lagoon. And right now I'm developing a research project to find out what would be the efficiency of a green filter project in the coastal areas of the lagoon. So obviously your project is of very high interest to me, to see what you have done and if anything can be learned that could be applied to the Mar Menor situation. So thank you very much. Looking forward to the presentation.
Thank you. Okay, and then we can move on to our partner from Slovenia, Municipality of Trebnje. Hi, Sarah.
Hello, from the Municipality of Trebnje. We are very interested into your best practices, because I think we could transfer something similar in our case. And we are very happy that several stakeholders decided to join our meeting from regional and national policy level, and some companies and researchers. And I would like to invite them if they would like to introduce themselves. For example, I can see from researchers, Matjaž Glavan, would you like to introduce yourself?
Hello everybody, I'm Matjaž Glavan, I'm from University of Ljubljana, and I'm also involved in several projects dealing with how to improve the water quality in the smaller rivers, or also how to clean the water from the wastewater treatment plants and use it on the agriculture fields. Thank you.
Thank you.
So next are from the company Limnos, Company for Applied Ecology. Can someone represent you?
Hello, everybody. It's nice to have the invitation and to be able to participate in the meeting. Yes, we are a company for applied ecology. We do design constructed wetlands, and we are eager to learn more about the practice done in your country. Thank you.
Thank you.
So I can see also Vane Urh is with us from Regional Development Agency.
Yes, hello, good morning from my side as well. Nice to see you again. With some of you, we have met in Lotskija region last November. I represent the Regional Development Agency. We are responsible for preparation and implementation of the regional development plan, where Općina Trebnje is one of the 21 municipalities we cover, and we are looking forward to include your project activities into our activities as well.
Thank you.
Wish a successful seminar. Thank you.
Thank you. So, Sarah, is there someone else, or it's okay?
Probably they will join us later.
Okay, they will join us. Okay, so thank you everyone. One more time, welcome. So we can move on to our good practices presentations. As it was in our agenda, we have two good practices that we will present you today. The first one is the surface flow constructed wetland, and the second one is rainwater reuse for service car wash. So to shake things a little bit up, we will start with the surface flow constructed wetland, and to give a bit overview of the place and of the practice, we will start with the video. We will now translate the video via YouTube. I hope everyone will see it. If someone has some kind of problem, just write it on a chat box, okay? And I think we can start with the video. So, yes. Does everyone see the video and the sound is clear? Just someone says me some.
Yeah, sure. It's excellent.
Okay.
Mēs atrodamies zemnieku saimniecībā Mežcīdu. Mēs atrodamies zemnieku saimniecībā Mežcīdu, nodarbojas ar piena lopkopību, raudkopību un dārziņkopību. Zemnieku saimniecībai ir 700 hektāru lauksniecības izmantojamā zeme, 300 slaucamas govis un 300 atlažošanas. Saimniecībai ir pushektārs ziemas siltumnīcas, kur audzē pārsvarā gurķus, dažreiz salātus, varbūt arī tomātu kādu. Saimniecība izveidoja vidzemes mākslīgo mitlaini, tāpēc, ka vēlējās iet laikam līdzi, jo saprot to, ka jebkur zemnieku saimniecībā veids kādu piesārņojumu, un līdz ar to tas ir tāds instruments, ko varētu labvēlīgi ietekmēt arī mūsu kopējo Baltijas jūras apdzīvošanas reģionu.
Here we can see the surface flow constructed wetland. This one is made as an in-stream constructed wetland. It receives surface runoff from the fields, from agricultural lands, and drainage runoff from agricultural lands. This one is 240 meters long, and it is made by transforming a simple drainage ditch. So here we can see the surface of the constructed wetland. This is the inlet, here is the road we can see, and the road culvert, and this is the inflow in the constructed wetland. As you can see at the beginning and at the end of the constructed wetland, there are made two small islands, as we can see in here. They serve to make the flow go through the longest way through the wetland. So it takes a longer time for the water to go through the wetland, and hopefully it is cleaned better. And then afterwards, water goes to the natural watercourse Agnese River and then to the Baltic Sea. In Latvia, actually, constructed wetlands are not very wide spread, not very popular. At least it was like that at the beginning when we built that constructed wetland. And yes, and that's why this one is as a monitoring object. We are taking water samples at the inlet and outlet of constructed wetland, once or twice per month, depending on the water flow, in the small half-liter bottles, and we are taking them to the laboratory to cake analysis. For total nitrogen, it's approximately 20% efficiency if comparing concentrations at the inlet and outlet. And for total phosphorus, it's approximately 45% and 15% for suspended salts. This constructed wetland was built in the year 2014 in the summer. Through the years, vegetation in this constructed wetland has evolved naturally. The main exploitation tasks consist of mowing the grass and vegetation in constructed wetland yearly, and besides that, you should take off the suspended solids. This constructed wetland is equipped with different measuring and monitoring equipment. For example, in here, you can see mini diver, which is measuring water level every 2 minutes. And so we can calculate the water flow in constructed wetland. Besides this mini diver, we are standing actually on the dam, which has Daina Ievina under there. So we can again calculate the water flow. In this monitoring station, we have different equipment for automatic water sampling, for measuring conductivity and water temperature. And yes, in the efficiency, I can say that the treatment process is going well through the years, and yes, we are satisfied with that.
Saimniecībai plusi no Vidzemes mitnēs ir tāda, ka izmantojam atkārtot šo ūdeni siltumnīcas dārziņu laistīšanai, jo ūdens ir daudz mīkstāks, kā rezultātā augiem neveidojās problēmas ar to uzņemšanu. Nenotiek arī laistīšanas iekārtas aizkaļķošanās. Protams, pozitīvais ir tas, ka no šīs mitnēņas baseina mēs izmantojam arī kā ūdens ņemšanu vietu, ja apkārtnē notiek kāds plūsdēks. Un, protams, arī izkliecē mēs izmantojam viņu peldēšanai.
Okay. So I hope everyone saw there were no problem with that. And now I give word to Linda Grinberga, our expert of this good practice. Linda, please take over.
Hello, everybody. It's nice to meet you today, and I'm really happy for the opportunity to tell you something more about my research object. In just a minute, I will open the presentation, so you'll be able to see some text material and some graphs. Basically, this object was made initially as a treatment system. As constructed wetlands in different countries, they are very widely used, and the purpose to build a constructed wetland can be very different. There are wide possibilities to use the constructed wetland. But in this case, in Latvia, we initially made it as a treatment system for the agricultural runoff, and I will shortly tell you something more about that. And what's more, I would like to tell you not only about the surface flow constructed wetland, but about both objects that are in the same farm, surface flow constructed wetland and subsurface flow constructed wetland. They are like separately made, but I think you could find some interesting points in both of them. So I'm sharing the screen. And let me begin my presentation. So hopefully it's visible. Yes, good. Okay, so I am a researcher and lecturer and different other duties in the University of Life Science and Technologies in Department of Environmental Engineering and Water Management. And my interest is covering the water quality and water quality improvement in natural conditions. Besides that, I'm giving courses in
in irrigation direction and hydroponics and some other directions connected with water processes, water quality, I would say. So, but about the object, I really hope that you know where Latvia is located, and my research object, the farm Meža-Cīruļi, it is located in the middle part of Latvia, and study site is located in nitrate vulnerable zone according to the criteria of EU Nitrates Directive, and that's why we chose to build this constructed wetland in this particular area. Besides, in the farm, the owner agreed to improve the water quality in this natural way. In Latvia, like telling something more about the background of constructed wetlands and about different kind of wastewater treatment in natural conditions, I would say that we are on the way, and we are trying to find more and more interesting and like appropriate solutions to make the wastewater treatment more sustainable, and constructed wetland is one of those ways. And when we initially started this this research in constructed wetlands to treat wastewater from agricultural lands, then at that time, at year 2013 actually was the beginning of the project. The constructed wetlands were not widely spread at all. At the moment, after the years already, wetlands are already more popular, and people are building them for different purposes, but still with the real monitoring, with real sampling process, with regular sampling, there are not very a lot of data available. So here you can see the view like plan material for my research object. Can you see my bullet of the mouse if I show it? Can you see it? Yes, great. So now I'm showing the surface flow constructed wetland. This is the surface area of constructed wetland. As you possibly understood from the video, then basically it was like a drainage ditch, like a simple drainage ditch, because maybe you know in Latvia we have runoff occurring every year annually, so we have to deal with the runoff to get the extra moisture away from the fields, from agricultural fields, and we do it with the drainage system, with ditch systems. So, and this leads to nutrient leaching to the natural water courses, and to get rid of it, to decrease this pollution burden to the natural water courses. This is a good solution, edge of field practice to treat the water or to retain the nutrients from leaching to the natural water courses. So we actually rebuilt one part of this drainage ditch just before the entering water in the natural water course here where I'm showing. So basically this all of this water which comes in this surface flow constructed wetland, this is from the catchment basin with agricultural fields. So this is one. But as I promised, I would really like to mention the other one, constructed wetland, which is like separate system, and it collects rainwater from the farmyard, with different equipment for agricultural processes, with cattle moving, with biogas station and so on, and with the hard payments. So the rainwater rains on the stormwater rains on the hard surfaces, and that rainwater is collected, and it is collected in the sedimentation pond initially, and then it is released with a pump it's pumped periodically to the subsurface flow constructed wetland, and yes, and I will show you some results about the quality of water, what comes in and what comes out for the subsurface flow constructed wetland. So yes, later I believe that you will be able to go through the presentation. You will see all the numbers. If you are interested, you can ask me some questions later. I will be happy to answer. So here's the view again for this surface flow constructed wetland, and basically it works already for years, and through all those years we have done a monitoring process, and the same with this subsurface flow constructed wetland. Here's just a cross section shortly to show you more detailed what is in the subsurface flow constructed, which is made for surface runoff from the farmyard. Basically, it's rainwater from the hard surfaces. And once again, all the numbers you can find out later or just ask me later. So here's it's filled with the gravel, planted with the common reeds or Mythus australis, which is a very good growing plant. That's why it was chosen in this case. And here is a view from the early spring, how the subsurface flow constructed wetland looks like. So this is this initial sedimentation pond. Here you can see a pipe which comes from the surfaces, from the hard surfaces from the farmyard. Water comes in here. It is collected for a while, and then here is a well, like a pumping station with a pump, and the pump releases water here to the horizontal flow subsurface constructed wetland. This is early spring, so you don't see any reeds, any plants above here, but this later you will see the results. That doesn't affect the water quality improvement anyhow. Yes, so basically this is already with some plants already beginning of the summer, as the seasonal impact in Latvia is very good visible. So if you would be here at this month, then you would see a completely different view to this object. So water goes from the farmyard and hard pavements to the sedimentation pond, then through the pipe to the constructed wetland, and then released back into the open ditch, and then goes to the with self flow goes to the water course, to natural water course. The methods, basically, we are taking samples for suspended solids, nitrate nitrogen, ammonium nitrogen, total nitrogen, orthophosphate phosphorus, and total phosphorus. And we are doing it once or twice per month, depending on the water flow. If there's no flow, we are not taking the sample. If there is a flow, then we are taking the sample. And yes, and the samples are taken at the beginning of the wetland and at the end of the wetland. And yes, and what is very interesting for this subsurface flow constructed wetland, the water contains a lot of organics due to all the cattle and due to all the equipment that is moving around the surfaces. And for a year, for this 2020, we are taking samples not only for those 6 parameters, but we are analyzing BOD and COD, and the results are so interesting. I'm very happy for that. I will show you later. So let's move on. Just a view to understand the situation in Latvia, because basically it is really dependent if you have runoff, if you have precipitation, if you have enough water resource, as this project is more about the water resources. In Latvia, basically we don't have a problem with the water amount. there could be a question about the water quality, but about the water amount, I wouldn't say that we don't have enough water. We have. So here you can see some data about the precipitation and about air temperature. Some tendencies very good visible is seasonality. Yes, and because of those winters, because of the climate conditions in this area, in the area of Latvia, I suggested, and we were using the common reeds as a vegetation for the constructed wetlands in both cases, because they are growing good without any special treatment. They are just growing. You just have to cut it regularly. Yes. Okay. Yes, and in surface flow constructed wetland, basically we didn't plant any reeds. They were just at the first year they were spread naturally, and now you saw the video that there are enough of the vegetation that is serving for basically it's serving for the bacteria. Yeah, so bacterial activity is the main thing that is treating the water in constructed wetlands. So the numbers. I would say that as this is the real object, this is not like a lab where you can easily set up the water quality, what comes in. In this case, it's even more interesting because the real processes are going on in the farm, and excavators are driving, and equipment is moving and doing their job, their daily things that they have to, and I'm just in the middle of that with my research object and taking samples and then trying to explain why do I have this or that result in this or that month. So here you can see the average numbers, and the average numbers are very promising, I would say. So maybe the percentage of retention would be the easiest and more understandable thing to look at. So the surface flow constructed wetland, yes, with minus, it means that the water quality at the outlet is better, times percent better than at the inlet. It means that retention is showed, is visible. And yes, and maybe let's move to the seasonal graphs, which is the most interesting part, I would say, in all this research. Here you can see the picture of surface flow constructed wetland at the summer and at the winter. And yes, and the first thing that people are usually asking is how about the winters? Does it work in the winter and so on? So here you can see that actually the best treatment process, like of course is retention. The best retention, of course, is during the vegetation period, but this is more due to the water flow and due to the retention time of the water in the constructed wetland. If you look from the point of view of treatment to this wetland, so because in the February there is snow melting waters and there is maybe some rain events, and the same in November when it's autumn, there is some rain events which increase like the water flow. Yes, and so the retention time is shorter. So maybe that would be the main issue with the retention efficiency for the constructed wetland. It's for the phosphorus compounds, and yes, and with nitrogen and with nitrogen compounds, it's more complicated, of course, because bacterial activity is more involved in different transformation processes, and yes, and besides that, the surface flow constructed wetland receives not only like the drainage water from catchment basin, but besides that, it receives periodically. There are some events when surface flow is coming in the middle of the wetland, and that's why those results are very interesting during different seasons due to activities in the fields. So, and yes, and for the subsurface constructed wetland, here is a proof that actually the winter or the lower temperatures doesn't affect anyhow the retention efficiency for the constructed wetland. So it's easily can be used for different kind of wastewater treatment in this particular hydrological conditions, because the only little bit lower efficiency is during the March, which is again connected more with snow melting waters, and it means the water flow or water amount going through the constructed wetland, and that's why this efficiency a little bit lower during this like months of March. Okay, let's skip to the conclusions, and maybe I will more focus on what is more connected with this particular project and with water water using, like sustainable using, because yes, as I told, this project is initially made as a treatment system. But when we made it, when we built it and started to exploit it and to do the monitoring, the owner showed us how this wetland can be used even more, not only for the wastewater treatment or for water quality improvement. So maybe it wasn't so clear in the video because of this echo sound and so on, but you are able to watch it later once again. But yes, the first thing is that near this wetland are greenhouses, and in this farm, this natural water course, this small igloo on the river, during the summertime, during the vegetation period, the water amount in this river is very, very low. There are now enough surface water resources to use for any irrigation. And the solution, as in Latvia, it's possible, and people are doing that. We are using groundwater for irrigation. And this owner in this farm, when we built the constructed wetland, he took some samples from his groundwaters, and took some samples and compared with the constructed wetland and water in constructed wetland, and now already 4 or 3 years, I'm not sure at the moment, but he's using the water from the wetland to irrigate his greenhouses, because water is softer. In Latvia, we have a problem with groundwaters that there are too much iron conditions in content in the water, and that's why it was more like appropriate water was to take it from the constructed wetland for irrigation. And besides that, he has some sensors on the inflow to the greenhouses, and he is just compensating the water amount, the nutrient amount for. He's not putting so much nutrients from the side. He's using the part that is already in the wetland. So that is the thing. And besides that, of course, he is using this wetland in different other ways for the recreation. For example, he's using it as a swimming pond, and he's fishing there. And there are living some fish, and for of course, for it's like a habitat, and for biological diversity is really it's increasing biological diversity. I have saw a lot of different animal and and birds living in this wetland, in the both of the wetlands while doing my sampling process. So yes, I think that would be it. In very high speed, I believe. My presentation has come to end. I would be really happy maybe to answer some questions or to open discussion if it's allowed.
Okay, thank you, Linda. We have some questions. We have 2 questions in the chat box. I will read them to you, okay?
Yes, thank you.
So, go back. So, first one is from Maria. How you consider, instead of using common reed for filtering, to use other types of regenerated filters, e.g. carbon nano tubes or something like that?
Yes, when we initially started this project, then the idea was to use as possibly natural conditions. So basically to use, to make it as possibly low expenses for the building process. And yes, and as for, we didn't use any like only natural materials. So gravel is put in the filter part of subsurface flow constructed wetland. That's why we didn't use any other carbon nanotubes or something. Yeah, we just use simple gravel with different layers to spread the flow and so on. And yes, and those reeds, common reeds, I understand that in different climate they can look differently, and there always is question where to put those reeds later, because they have to be moved periodically. In Latvia, it's recommended once per year. Basically, in the springtime, we are taking them off together with all nutrients they have gained, and we are taking them off. And then in the spring they are growing once again, the new ones, the new plants. But yes, where to put those old ones which are removed from the wetland, basically in this farm there are biogas station, they are putting them in the biogas station, and the amount isn't very big, because for the subsurface flow constructed wetland there's only 30 square meters, so it's not much. So it's, yeah.
Okay, thank you, Linda. I hope this answers many questions. Yes, okay, great. So let's move to Sasha's question. How do you judge the maintenance interval of the surface flow wetland caused by sedimentation?
Yes, this is a really good question, because we are we are judging it by during the exploitation, actually. For now, the wetland is exploited already 6 years, and only once they have moved away the sedimentation from the inlet part of the constructed wetland, if we talk about the surface flow constructed wetland. But it depends, depends on the catchment basin. If there would be some other soils, then possibly the suspended solids would be more in the amount, I mean, so it maybe could be even more often to take them off. But in our case, yes, we are measuring the depths of the wetland periodically. It doesn't change, so we decide that there is not so much suspended solids at the wetland.
Okay. Thank you, Sasha. Does this answer your question? Okay, I hope yes. The next one is from Sarah. So it's more like a comment and then the question. So in Trebien, Slovenia, we have a case that potentially we could build a wetland close to the river stream, which means that in the case of floods, few times per year, the wetland would be flooded. Which problems could we have? This is the question.
Yes, if the flood will contain a lot of suspended particles, then wetland could get clogged. And that could be a problem because the filtration is very, very important for the wetland. But in the case if you are choosing to build surface flow constructed wetland, then flooding has no problem.
Okay, thank you. Manuel, would you like to ask your question yourself? Please unmute yourself. Manuel, you are still muted. Yeah.
Can you hear me?
Yep.
Yes,
Please.
I have to ask for two questions. The first of all, of both is about the sanitary conditions, because especially the problem of mosquitoes, if there is a household close to the wetlands.
Mm-hmm.
And the second one, oh, okay.
Yes. In Latvia, the situation is such that we don't have a problem with mosquitoes. But talking and looking through the research about the constructed wetlands, then in that case, if it's located too close to the living areas, then it's suggested to choose subsurface flow constructed wetland, where the water isn't visible above the filter, and in that case you can avoid those mosquitoes more.
Mm-hmm. Okay, and the second question is about if there is any aquifer under the wetlands, and if there is any infiltration on the quality of the water of the infiltration in this case.
Yes, this is a very good question. Thank you. It depends on the water quality that you receive. In Latvia, we were basing on the legislation, basically, and for agricultural runoff, there is no any limits, no, well, except nitrates directive, of course, but basically you don't have to isolate it from the groundwater. In this particular object, we haven't found any aquifers that is coming in the wetland, but there is no hydroisolation too. So I mean, there is occurring some infiltration to the lower parts, and we are receiving at the outlet, we are receiving less water that comes in, I believe. But for the subsurface flow constructed wetland, it is hydroisolated. It's completely, so what comes in, the same amount comes out, if we talk about the quantity of the water.
Okay, thank you.
And we have some few more questions from Jamie. What was the budget for the installation? I will read all of them because they are short. This was the first one. What was the cost split with the owner? And the third one, what about the maintenance costs? Yes.
Yes, we built it together with WWF, Latvia and Sweden. And the huge part, I would say 70% was from the project, and the last 30% was for the owner. And yes, and all those costs actually is, the main part of building costs is excavating. And that's it. If you don't have to take samples, you don't have to build this concrete this dam, then it's only excavating. I mean, if you have excavator and gas, this oil, then you can calculate the cubic meters, and that's it. And yes, for the maintenance, again, the thing is that you have to take care of the wetland with the vegetation periodically. Then is sediment part, which you have periodically, time after time, dig off. And if we talk about this subsurface flow constructed wetland, then the main cost is a pump, a water pump, because there is some amount of electricity needed, and the water pump have to be just changed periodically because it breaks time after time. So those are the costs.
Thank you, Linda. We have up here 2 more questions for you. The first one is from Camilla. Have you considered to construct the sedimentation zone with the pond at the inflow part? This seems to work fine in Lodz, Poland case and avoid using pump. So.
For the using pump for the surface flow constructed wetland. Was that the question?
I guess.
Probably.
Yeah, I guess.
For the wetlands, actually, there are a lot of combinations possible. And to decide what kind of wetland to use in this or other way, you have to know 2 things. How many area do you have? And what is the water quality and amount incoming? Quality and amount, 2 things. And then you can already decide if you have to remove ammonia, but then you need oxygen. How to get oxygen? With that or other kind of wetland, like technical. This is already a technical thing. So yes, if you consider that you need for that water quality that you have, you need a sedimentation pond, like separate one at the beginning, then yes, it's completely possible. And with the pumping things is that if you choose like natural system, then I would suggest to avoid all electricity consuming equipment because first it breaks time after time, and secondly you need electricity all the time. But if it's natural system, then try to do everything maximally with the flow system. In this case, it wasn't possible to build without the pump, this subsurface flow constructed wetland, because this rainwater collecting system already was built, and we didn't have any possibility to change the relief in this case, so we chose to build a pump.
Thank you. The Camilla specifies the question.
Okay.
So the constructing, this is mentioned with the pond at the inflow part. So the question is about constructing sedimentation zone at the inland part of the pond. Okay, and she's fine now. Just okay. And the second question is from Yuan. Could you make some comments about the hydraulic retention time of the water in the treatment?
Yes. It depends. It's you can calculate it actually how it is the main thing that tells you the volume of the wetland. If you choose to build surface flow constructed wetland, then it's just cubic meters of the water that you have to build for the water. And for the subsurface flow constructed wetland, basically it's more connected with filtration ability of the gravel that you use. Yes, I don't know what else to tell. The retention time, yeah, I mean, if you calculate only inflow and outflow and maybe precipitation amount and evaporation, that are the main things for the constructed wetlands or the hydraulics of the constructed wetlands, then yes, then you can easily calculate how many days or how many hours water is kept in constructed wetland.
Okay, thank you, Linda. Do we have some more questions that you want to ask straight to Linda, not like in the chat box? Please, this is the time. Okay, if no one has questions, then Linda, thank you for a very interesting presentation. We had lots of questions. I would thank you for all of the questions. And Okay, let's move to our second good practice, okay? So as we started with also with the video, we will start this time also in the video. I saw in the chat box that there was some echo. Sorry, it was our fault. We will start the video and then we will pause it just to make sure and ask you if the echo is still like echo or is the sound good, okay? Okay, so let's try. Just a second. There is that. I need to, yeah.
Pasūtītājs mums bija Latvijas autoceļu.
Does the echo sound is still there or now is sound good? Someone please give. Tell me. Good. Thank you.
Pasūtītājs mums bija Latvijas autoceļu direkcija, Latvijas autoceļu uzturētājs. Problēma ir tāda, ka praktiski visi šie autoceļu uzturētāji darbojās jau no padomju gadiem, un viņu laukumu rekonstrukcijas pārsvarā nekur nav veiktas. Līdz ar to šeit pasūtītājs ir no Kandavas, un Kandavas autoceļu uzturētājiem bija problēma, ka lietus ūdeņi visi sastājās uz laukuma, daļēji palika uz šī asfaltētā laukuma, daļēji paštecē aizgāja uz zaļo zonu bez attīrīšanas, un vislielākā problēma bija tā, ka uz šī paša laukuma mazgāja visas mašīnas, smagie transporti, ceļu tehnika, pēc greiderēšanas, ziemā pēc sāls un smilšu maisījuma, tātad kaisīšanas uz ceļiem, un visa šī zupa, kas paliek no mašīnām, pēc mazgāšanas tā visa aiziet šeit dabā. Līdz ar to griezās pie mums pie projektētājiem. Pasūtītājs ar lūgumu atrisināt šo situāciju, lai viņi varētu turpināt mazgāt bez problēmām šīs mašīnas un nepiecūkot apkārtējo vidi. Mēs izpētījām teritoriju, apskatījām esošos laukumus, ēkas, noskaidrojām, cik liela ir, kāds ir tehnikas daudzums, tātad, un sākām veikt aprēķinus, cik lieli lietus ūdeņu daudzumi no šīs teritorijas tiek nodīti apkārtējā vidē un cik ir nepieciešams ūdens, lai mazgātu šīs mašīnas. Un konstatējām, ka mēs varam šo lietus ūdeni pilnā apmērā pēc attīrīšanām izmantot arī autotransporta mazgāšanu. Projekts tika izstrādāts 2012. gada oktobrī. Un nākošajā gadā vasarā arī realizēt šo projektu. Kā rezultātā tika nolemts, pasūtītājiem piekrītot, ka mēs saglabājam esošu asfaltēto laukumu, tikai izbūvējam jaunus bortakmeņus, lai norobežotu lietus ūdeņu un mazgāšanas ūdeņu plūsmu no zaļās zonas. Paredzējām zemākajā vietā izbūvēt lielas restotas teknes, trapus, kurā šo visu lietus ūdeņu, mazgāšanas ūdeņu daudzumu mēs savācam un tālāk ievedam attīrīšanas ieteices. Un attīrīšanas ieteices mums sastāvēja no divām daļām. Pirmajā daļā mums bija liels smilšu ķērājs, kurā nostādināja visas smiltis, netīrums, suspendētās vielas, visu, kas no mašīnas tiek nomazgāts. Un tālāk, kad šīs ūdens ir nostādināts, tad viņš pārtek uz attīrīšanā, kur savukārt tiek saķerts un atdalīts naftas produktu piesārņojums, eļļas, aromātiskie ogļūdeņraži. Un praktiski pēc šīm attīrīšanām jau tālāk tīrs ūdens tiek uzkrāts tvertnēs, kuras mēs noizolējām, lai nebūtu iedarbības apkārtējo vidi. Tāpēc mēs izvēlējāmies iekārtas, kurās bija koalescences filtrs ar sorbentu. Otrs bija biobloks, un biobloka strādāšanai ir vajadzīgs skābekļu pievada. Šo ūdeni, kas tiek uzkrāts tvertnēs, tur vairāk kā 5 kubi tvertnē ir, izmanto tālāk laistīšanai. Viņi ir izbūvējuši mājiņu pie uzkrāšanas tvertnes, kurā viņi glabā karčera tipa lielo augstspiedienu mazgātāju, kas ir pieslēgts šim rezervāram, un tālāk izmanto pēc vajadzības automašīnu mazgāšanai. Un tā veidojās šis slēgtais cikls, ka to pašu ūdeni, ko attīra, uzglabā, to izmanto mazgāšanai, attīra vēlreiz un izmanto, cik reizes ir nepieciešams. Attīrīšanas ieteicis ir 20 litriem sekundē, aptuveni tikpat arī lietus ūdeņu daudzums ir tāds lietus gāzēs, kas nonāk šajās attīrīšanās. Vienas automašīnas mazgāšanai vidēji aiziet līdz 800 litriem ūdens, un mums ir 5 kubikmetri tvertne, kurā var šo ūdeni uzkrāt. Līdz ar to jauda mazgāšanai ir 5 automašīnas vienā dienā. Tātad esam izbūvējuši jaunu dzeramā ūdens pieslēgumu, jo tas bija nepieciešams kaut vai tāpēc vien, ka attīrīšanas ietaises arī ir reizi gadā jātīra, viņas ir jāapkalpo un tur ir vajadzīgs tīrs ūdens. Un nevienmēr lietus ir nogāzes, lai šo lietus ūdeni varētu izmantot skalošanai. Un tāpat arī karčera tipa iekārti pa laikam ir jāiztīra, jāsakārto un tad šo dzeramo ūdeni var pieslēgt un izmantot sistēmas skalošanai. Gala ieguvums kaut vai tāds, kad dzeramais ūdens ir jāizmanto tikai tajos gadījumos, ja ir ilgstošs sausuma periods. Visā pārējā laikā mazgāšanai izmanto šo te lietus ūdeni, kas ir attīrīts, par to nav jāmaksā. Tas ir viens. Otrs, reģionālā vides pārvalde ar pārbaudēm atbraucot šeit nav konstatējusi pēdējos 8 gados nevienu piesārņojumu, līdz ar to arī nav nekādi sodi. Kā paši darbinieki saka, arī feini ir apkārtējā vidē nodrošināt to tīrību.
Okay, I hope the video was fine. I hope there wasn't any echo sounds this time. So we will start our presentation regarding this good practice. So, Adelaide, could you share the screen? The first slide. So, I will be doing this presentation. With me is Daina Ievina, who is the detail designer of this good practice and also the lecturer of Latvian University of Life Science and Technologies. So she will be with me today. If you will have some questions or if I will say something less than I should, Daina will control me and tell me what to add. So our second good practice is rainwater reuse for service vehicle car wash. So as you know from previous presentation where Latvia is, so this is where Latvia and Kandava. Kandava is the municipality where this good practice is implemented. This practice is implemented in the territory that is under the under the Latvian Ministry of Transport. So under this ministry, there are this company called Latvian Road Laying Maintenance Company. This company manages state roads. And this company has more different units within Latvia. And now we are speaking about the Kandava municipality where this good practice is implemented. The problem, what kind of problem they had? As you saw in the video, these areas, these territories where they are holding their transport unit, where they're washing them, they were built in the Soviet times. So till then, till the good practice was implemented, nothing was done, and all the all the things that were washed off the cars went down straight to the nature. So the problem was that firstly, you need to wash cars regularly. Every day you need car wash. If they are going out, then when they are coming back, before storing them in the garage, you need to wash them. So the regular washing needed to be done. And at the same time, also, as there were no purification of the water, the environmental board each year gave a fine for this unit, Kandava unit, transport unit. So there will also, they had also pay for the penalties. So the customer, Kandava unit customer, came to detail designers to manage this problem and to get the best solution so they can continue to wash cars and don't pollute environment. A little bit more about the problem. Why this was so important regarding the environmental aspect? Because Kandava are in a nature zone above Sanienleja, where the Natural Environmental Board gives a stricter specifications. So you need to be very aware how much purification needs to be done, and they are stricter, as I told you before. So and also they had pretty high expenses because they also had to use drinking water for the washing machines. So, and the drinking water tariff is almost €2 per cubic meter. And as you can see in this picture, I hope everyone sees my bullet. If not, please tell me. This gray area, this is all paved area that collects waters to this pink area. Now there's a treatment plant now that I will show you later, but before this treatment plant, all this went straight to the nature, so without any kind of purification. So when they were calculating the system and all the technical aspects, also they needed to take into account the technical regulations issued by the environmental board. And regarding, they were more stronger than the usual the technical regulations, and suspended solids had to be lower than 35 milligrams per liter, and the oily products had to be less than 3 milligrams per liter. And all these calculations were done for the flow, for the rainwater flow, for 20 liters per second. And after the calculations, they understood that all the rainwater that comes within the to this paved area can be used in a full amount for this service car wash. So the treatment plants. The treatment plants consist of two parts. The first one is the sand catcher. Here you can see the sand catcher. And the second one is for the oil separation tanks. And this is the picture from above. You can see here under the transport is the trap where all the waters, all the washed waters are infiltrated. Then after this, it goes to the sand catcher, this one. Then from the sand catcher, it goes to oil separation, these two. And then the clean water goes to two 5 cubic meter tanks. This one here, and the other one is under the house. So the treatment plant itself. So here we can see the water flows into the sedimentation or sand catcher. Then when all the sedimentation is settled, then the clean water flows to the second treatment, to the oil separation. And also this oil separation is also in two parts. The first part is BioBlock. Yes, and for BioBlock to work, there should be an air compressor. And this is the part where all the smallest oil the biggest parts are separated. And when the biggest oil parts are separated, then it flows to the second oil treatment, and this is the coalescent filter with sorbent. Yeah, coalescent filter with the sorbent, and this collects smaller parts of the oils, and then clean water flows into the storage tanks. And this is how this closed cycle of rainwater is treated and reused as many times as needed. So for one unit to be washed, it should be from 500 to 800 liters. So in a day, the approximate number is 5 to 8 transport units per day. So construction of the system was done in 2012, and then we had lots, not the euros, but in euros it's more than 4,500 euros. And when all these calculations were done before they implemented this good practice, they had to do calculations for monies, for financial savings for next 5 years. And when they did the financial calculations, the approximate, they said that the financial savings will be more than 2,000 euros, but the actual savings for the customer within 5 years had been more than 4,000 euros so far. So, and they are also cleaning the system, of course, because the system needs to be cleaned once a year. Unfortunately, the customer is not so keen sharing the numbers, how much is for the cleaning, but they have a contracted, the service contractor, who are then treating these treatment plants. And yes, and that's basically very simple system that could be used. So the benefits first, and then actually the main benefit is financial saving, because drinking water is used only if there are really long periods of drought. And for rainwater, you don't have to pay anything. So there's a huge financial savings. The other one is clean environment, because you don't pay fine to the firstly, you don't pay fine to our environmental board. And of course, there is no pollution to the environment. Also, awareness raising. Maybe this is in a way not so important, but in a way it also is very important, because all the employees see how to use in the sustainable water resources and how to sustainable use rainwater, and also replicability of this good practice. And this good practice is now already in 3 projects in Latvia now. One is already built. The other one is in stage in build procurement procedure, and the other one, the third one, is in detailed design stage. So yes, so there are some and other also units are also interested in this rainwater reuse, good experience and implementation. So thank you very much, and questions are welcome. So we don't see any questions in the chat box. If you, I guess then everything is clear for everyone. So, okay. Yeah. Okay. You have no. No. Okay.
I think, Agnes, I think this is very difficult. Everything was very clear in the presentation, and it's very easy to replicate these good practices in other place. because all the procedure to implement this good practice is perfect explaining in the presentation. I think that's why there is
no more questions. Okay. Also, one more thing that I wanted to mention, maybe that I didn't said so clear. In case you also saw in the video, there are additional connection for the drinking water built, and also in the if there are too much rainwater, then there's also built overflow, but still all the water goes through the treatment process, and then it just goes to the after the treatment to the nature.
Mm-hmm.
Yes, so this is also taken into mind. Yes, and the system is easy to maintain and have some financial savings for the customer. So, and also if you need some calculations, how the calculations were done, Daina can prepare them and send them also via mail. So we have question from Janko. No, there are no other costs. The only costs you have, like the first building costs to building the system, and then once a year to cleaning the system.
Yeah.
And that's it.
Yeah.
No more other costs. Thank you, Janko.
Mm-hmm.
Is there a patent formulated for this project? No. No, it's not patent formulated. No. Just thank you. So it's the specification is there, and it's for public institutions, so it's available for everyone. Thank you.
Okay, thank you.
Thank you. So I think if we don't have any questions, please, you have one last chance for the questions. So we are very good with timing, I think, more or less. So thank you everyone for participation in this meeting. I hope these 2 hour good practices of Latvia were interesting to you. If you have some questions after our meeting, please do not hesitate to contact me. I will transfer questions to the Linda or Daina, or you can write them directly. The contacts were also in the info document. Yes, I think we can finish. We can finish. Okay, thank you very much. Hope to see you all in some other site visits. I'm quite happy that I saw so lot of you today, and wish you all the best. Stay healthy. The most important part, stay healthy. Okay.
Thank you.
Bye.
Bye.
Thank you,
Thank
Elena.
you.
Bye-bye.
Bye.
Have a good day.
Thank you. Bye.
Bye.